Let's begin our discussion on architecture with the reason that we want to cover it, and that's software architecture. How does architecture apply to the software development process? Well, software architecture is all about breaking up larger systems into smaller, focused systems. This gives us a lot of different benefits, not only to reduce costs, but to help make it easy to develop, to help make it so our engineers aren't standing by idly waiting for other people, and so many other different things. So, some couple of key aspects here is that good architecture is hard. It's not something that's easy that we can all do, and that's why a lot of people avoid doing this part. Is because it takes some thinking, some creativity to come up with good architecture. And a lot of people just want to get in there and start coding, so they don't even think about the architecture. And when you do that, you build something that's known as spaghetti code, where you start building one file and then you build another file, and then you're like, wait, that needs to link there. So then we have another file and like, oh, that needs to link there too, but it also needs to link up to this file. And slowly you start getting this web, this spaghetti web of code going together. And instead of having this nice, maybe organized architecture where maybe everything contacts a central server, or there's a constants page that has everything. So if we want to change something, we only have to change it in one place. You start getting this really strange web of calls and things like that. And it becomes very hard to trace down problems, because maybe the problem starts here and it calls the wrong function here, which then makes it break an aspect here, which makes it go back into here and call another wrong function, go up to here, and then over here. So this is where we think the bug is, and now we have to backtrace it, do all of these calls to figure out that, oh no, it was actually a line of code over here. Where over here, we have less of those connections, and maybe the break is up here, or maybe the break is down here, and it just manifests here. We can do a quick backwards look, and we see it's right here. Now, of course, those are just like very hypothetical things, but that does happen a lot, is that if we have a very clean architecture, breaks are easy to find. Good architecture also allows for faster development and smarter task allocation. This is important because it enunciates the point that it's going to save us money over time. If we can break up our architecture into something like this, then we can say we're going to have engineer 1 work on a task in here, and engineer 2, and engineer 3, 4, and 5, and we can get 5 different tasks developing at once. Where if we just have one giant file, or maybe even like just 2 giant files that sort of communicate back and forth with each other, how are we going to get 5 engineers working on different tasks? Well, we could have them, maybe all work on the same file at the same time, but that would actually cause usually merge conflicts, which means like I worked on code up here, he worked on code down here, but to get his code to work down here, he or she had to go ahead and change something up here. So now I push my code, he pushes his code, and suddenly there's this big conflict. I'm changing code, he's changing code, and we'd actually have to come together and go line by line to fix it. It's a very painful process. So in that situation, what a lot of times happens is if we both need to work on the same code, you just have to wait. So, engineer 1 completes his task, engineer 2 completes his task, and now engineer 3 can finally jump in there and start completing her task. So it's something that reduces the overall idle time if we get good architecture, and allows the company also to decide where to buy and where to build. If we have something like this and we're like, we only have maybe 4 engineers, well, maybe there's a good solution out there and we don't need to spend all the time developing it. So instead, we just say, okay, we'll work on these, and we'll just go ahead and purchase something that fits that. Maybe it's like a form or something. There's many, many great form things online, form little projects that we can buy and integrate into our software. So that allows us to choose the buy or build. And then overall, we always need to remember that architecture mistakes are almost impossible to fix once coding has begun. Once we begin, it is impossible to sort of take this and make it that. And whenever I say impossible, I don't mean it's like just not possible. There's no way you could ever do it. What I mean is that it would cost more in both time and money to fix this than it would be to build a new product like this. So for example, if we had an existing product right here, to make it like this, we would have to spend more money than it would take to just start over, to delete everything and just begin from new. And that's what I mean when I say impossible to fix, is that cost disparity between the two. So let's go over like a little example here, something that we can sort of just have an idea about. Let's say that we're creating a website. And so we start with this bad architecture at first. So we have a single web page that has maybe 1,000 lines of code in it. Or for this example, let's say it has 10,000 lines of code in it. If I tasked you with finding a certain element in here, how easy do you think it would be? How many different calls do you think where you'd have to go from here down to here, over to here? Do you think would happen whenever you go to a 10,000 line document? And this is a small website. I mean, there are websites that have 100,000 lines of code. Imagine they're all on a single one. How would you break it up so that, I don't know, maybe 15 engineers can work on this? Think about that. Let's say that the next step of this is, okay, we don't want our entire website on a single page. So instead, we're going to be like, well, we need let's say a front end. So we have the front end, and then we need a back end. So now we create two files. We have the front and the back, and they communicate with one another. Getting a little bit better. Now we can actually put a back-end engineer over here, a front-end engineer, and if we have, for example, a button shows up as the wrong color, we know maybe we're going to look at this folder instead of this folder. You know, this one's got maybe 5,000 lines, or in this situation, 50,000 lines, and this one has 50,000 lines. Makes it just a little bit easier to find out. We don't have to go through 50,000 lines of things that just don't even matter. We have only front-end stuff. And then now we can start breaking it up into, instead of just front end, maybe we have the web pages broken up. So we have a main web page here. We have maybe the login page over here. And then we have the form over here. And maybe the form is only 100 lines. And then the main page is, you know, maybe 49,000 lines. And then the login page is something like, you know, maybe 900 lines. So it's still those 50,000 lines. But we have, and then we'll just keep the end over here, or the back end. Yeah, that should have been back end, not just end. So front end, back end. So we have the back end over here that's still communicating, but now we have a little bit better of an idea about how it's communicating with things. And now we have this broken up just a little bit more. So we have the ability that if we say the button color is wrong, we can go into the file and we're like, well, it's on the form page. Let's go check out the form page. We read through the 100 lines. Yep, right there, make the change. So as you see, as we break it up more and more and more, we start to be able to maintain this project a little bit more, and we start to be able to basically create a better product that we can expand over in the future. So now that we have just sort of this very, very general idea of what we're doing with architecture by breaking things up, let's start going over a couple of, they called patterns or models, different ways that you can take your project and break it up, and some of the sort of tried and true methods of doing this.